Hello, students. As usual, I have to greet you by that. I don't know what time of the day it is. If it is afternoon, then it's afternoon. But what is more important here is getting to business. Right. Remember what we have been discussing in the previous videos. By the link we have down here, I think you are there connected already. If you have not done so, please can you go by the link so that you have to see what we're going to discuss from today. Right. Informatively, let me inform you that we are having the last lesson in the transformation. So can you please let us finish it together. Right, all in all, we already started looking at the issue about the enlargement at the last part of the transformation in the previous video. So this is the third one. This time around, we're just going to finalize the discussion about it. Like, just to take you back a little bit, let us try just to look into it, that say the things that are required, or say points to consider each time you would like to enlarge a particular figure. So enlargement demands you to get to know about what is known as the center of enlargement, right? Secondly, you need also be able to know what we call the scale factor. Right. And lastly, at least as a student, be able to know some issues that are related in terms of the nature of the image and also the center of enlargement once you are enlarging a figure by a particular scale factor. That is to say, if the scale factor is less than 1, as I indicated, we have to expect that the image generated out of it must be smaller as compared to the object. But if now the scale factor is greater than 1, comparison is between the 1, it means the image is always greater than the object. On the other side, if you find that whatever scale factor you have is maybe say negative number, like -2, or -3, -0.5, our expectation is that once you are going to enlarge a particular figure, you need to expect that the resultant image must be upsetted. That should be upside down, and the center of enlargement must be in between the two figures. That's the image and the object. Like, just maybe to give you a cap of it in brief so that we know what it is about that, and then be well connected with what we're going to do here today. For example, if we can have triangle ABC, right, and you decide to enlarge ABC, we expect it to have a greater image if the scale factor is greater than 1. Something like, if I'm going to maybe extend this one, for example, twice as much, it means whatever distances of this figure here must be 2 times as much. So for example, let's just take it that say the result of the enlargement of that one twice as much, we get a shape like that. It means this side here defined as the A prime, B prime, that is the image of AB. And side A prime, C prime, that one defined as the top of the image of AC, and B prime, C prime got the same with the image of this one here. So if this one is enlarged to twice as much, we expect the figure to be greater, to be something like this one here. So this is defined as object, this is your image. Now the issue about the scale factor and the center of enlargement. In this case, suppose we consider, as I've already indicated, this is the object, this is the image, and now we might be asked to find the talk of the center of enlargement that was talking about, something that guides up the enlargement in this case. To find that, what you would do in this case, you need to connect the corresponding points, one for the object and another one for the what? For the image. So like in this case, for the object we have got A, for the image we have got A prime, so you're going to connect A and A like this one. After that, you have to extend the line downwards like that. And after you connect C and C prime, to have a line which is like that, and this one has to be extended like that. Right, I know you can do better using a ruler, but here it's just like a guide which I've already done in the previous lesson. And then we're going to connect B prime and B prime, so you have got a line that goes like this. So what you should expect in this case is that the moment you do that, if you have drawn these ones now to scale, your expectation is that this will always be a straight line. It will go somewhere, this was a straight line, will go somewhere, and this one is a straight line, will go somewhere. The end point of which will be that these lines are going to intersect at one point here. And that's it. No matter what, modes that we are going to enlarge one object by a particular scale factor, you have to expect that the lines connecting the top of the object and the that's the image points that always to intersect at one position here. So this point here is the one that is defined as what? Center of enlargement. Right. 2, it's about the scale factor. Say we have got this triangle here and that triangle. We are told that this is an image of this one here. And somebody will ask you to just like how many times has this object been enlarged? It simply means to me what is the scale factor. Because from a definition I earlier pointed out, say scale factor is just like telling us how many times are you going to enlarge a particular figure. So like say we have got this one and that one here. Somebody asks you, can you find the scale factor? Just like how many times has this object been enlarged? So to get that number of times, what we do is this. We use a particular formula that is defined as it's more like a ratio. You talk of the image, that's a distance. 2, that is talk of the object distance. So when you divide the image distance by the object distance, what you're going to get is what is known as what? Number of times a particular object has been what? Enlarged. In this case, you are there going to find the scale factor of which by dividing that by this. So now if you come here, when you talk of the image distance, which is this image distance we're talking about? Image distance can be in any of 2 folds. 1, you look at the distance from there, the center of enlargement, up to that. If we are considering point A and A prime for the image. Object distance is the distance from here up to that. Let this one maybe be X. And the image distance here, you'll be talking of a distance from here up to that. That is your image distance. So what you do here in this case, it means what we're going to do, it means just amount of coming up, dividing the distance from here up to that, which can be sometimes defined as maybe talk of a y. That y should be divided by what? By x. So just like how many times does this one get into y? That is your object distance. So if it's from here up, that is maybe talk of 8 centimeters, and from here up that it is 4 centimeters, then what you have there is just like you take 80 instead of y, you divide by what? A 4. So it means that case, it means this object has been enlarged to twice as much. Or else you look at the corresponding sides of the object and the image. Like here you can just choose one pair. I may consider AC. This can be defined as the object distance, and we talk of the side corresponding to AC is A prime, C prime, and this one is defined as the what? Image distance. So what you have there, it'd be like scale factor. You talk of the number of times this object has been what? Has been enlarged. You be like A prime, C prime. Let me light up here. You talk of the A prime, C prime over that is what? AC. Apart from saying this distance here up to A, let me have this one as O, OA, that is prime over what? You talk of what? OA. So both descriptions are going to tell you how many times has this object been enlarged. Right. Now at the moment in time, I would like us to enlarge an object on the Cartesian plane. Right, so now this is just like done on the pen paper, but remember what we always expect here, most of the problems will come when we are trying to consider issue about the what? Coordinates. So can we now have this discussion on the Cartesian plane? Right, so with me here is an example where we asked to enlarge a particular triangle which is drawn on the Cartesian plane by a particular scale factor. So can you copy this one as quickly as you can, because I'm going to lab it, or just take note of it. Then that we'll have to discuss how we can go about this. Right, so whatever is done here, can you connect with what we have already done in the previous video when we started looking at the enlargement? Their enlargement was done just on the plain paper, this now on the Cartesian plane. So our example is this one, right? So here we are given a triangle. They say triangle, I'll take the width, that is ABC, in which this triangle has got vertices like A is found at 2, 1, and B is found at 4, 1, and then we have got C is found at 3, 4. What we're asked here to do is just a matter of trying to enlarge. We have to enlarge the triangle ABC. I'm taking breath. Right. Now, using what? Scale factor of a 2. Right. With what? Center of enlargement being 0, 0. Right. So that could be the possible type of questions we should expect. We have a triangle here with vertices A found at 2, 1, vertex B found at 4, 1, and vertex C found at 3, 4. So what we're asked here, first we are going to enlarge this one with a scale factor of 2. So it's more like we're going to double the size of this one, triangle. Right. So here we might also be asked to draw both the image and the object on the same Cartesian plane. So what I'll do here, apart from enlarging, we need also be able to at least understand how we can draw both the image and the what? And the object as such on the Cartesian plane. Right. So let us now consider this one as it is. So which means in this case, in your case, you take it for granted that say if I have got a triangle here, my expectation if I'm going to draw this triangle, it means the Cartesian plane to have it A, B, C like that. So our A is having talk of the coordinates 2, 1. So it'd be like now, if I am going to enlarge this triangle, what would be now the new coordinates of A? Right. Because I don't think this triangle will be at the same position with this A fixed at that same point. We have to expect that the position of A should be a different one. So it'd be like now, if this one has been enlarged to twice as much, where will be the position of A? So what you do in this case, you have a new position of A, which is now your A prime, that's the image of A. You work that one by simply multiplying these coordinates by a value which is a 2. So it would be like 2 times 2, you get a 4. 2 times 1, you get a 1. Right. So this is object point, this is the image point of A. Next, where will be the position of B? If at the moment B is found at 4, 1. So you do the same with your scale factor, which is a 2. It means this one has to be multiplied twice as much. So you have a 2 multiplied by 4, you get 8. 2 multiplied by 1, you get a 2. That's it. Then after, you also consider a vertex C currently is found at 3, 4. So it'd be like now, what is the image of point C? Right. So that should be defined as C prime. The new that's a position of C will be defined by the coordinates after multiplying these coordinates by 2. So it will be 2 multiplied by 3, you get a 6. 2 multiplied by 4, you get 8. Right. So with me here, I've got 2 sets of coordinates. One is set A, which give us issues about the object, which is ABC as a triangle, and another category is a set that is defined as about the what? Image of the resultant enlargement of that shape. Right, so now let's get into the Cartesian plane and see how this one will behave if with the what? Center of enlargement being it x0, y0. Right, so what is needed here is an issue about graph paper. So with you there, if possible, can you have a graph paper and we do this activity together? Right, so my graph paper in this case is represented by the graph board, which is this one here. Right, I know you have your own graph paper. If you don't have, just draw the y and x axis, then we use that one out. So what do I have? What I'll do, I'll select one line here to present as the main y-axis and one as x-axis in such a way that all these coordinates has to be fixed in. So let me have here this one as my line of selection. I'll choose this line here. I think let me use this line here. Right, you can choose any line here as your y-axis. So this is my y-axis, and again I'll have this one here as my x-axis. Look at this. This is the graph paper I have. Mine is a graph board. So I'll insert a scale in such a way that I have everything about the points of the object and the points of the what? Of the image. So what I have here, as we know, this is the y-axis, this is our x-axis. At the point when the two lines are intersecting, this is the point of origin, x0, y0. So then now, what next do? I need to produce the scale against the y-axis. So what I'll do, I'll first of all check which is the largest value of the y. So I'll see here the value of y is 8, but here the largest y is 4. So comparing 4 and 8, 8 is the largest. So here it means my scale will go by 2, like 2, 4, 6, 8. That now is okay with me. So you have a 2, this is 4, this is 6, this is 8. You can even have what? A 10. But 10 is outside. So here it means we're safe. If you can look around here, we don't have a negative value for y. So you can just have only one, just like a representative on the negative side of the y-axis, like that. Considering issue about the x-axis, I'm also going to check that which is the largest value of x. By upon looking at the things here, I would see that the image, the largest coordinate for x is 8, and the largest value of the coordinate of x is 4 on the object. So 8 is the guider. So whatever I'll do here, I have to stop at 8. So let me try to have my scale for 2 centimeters representing 2 units. So it'll be 2, 4, 6, then 8, like that. So I can also have a 10 here. Right. This side, I just have -2. So that is my scale. Next, what is that I'm going to do? What I'll do, I'll just see, at least indicate the points of the object first, right? That is A, B, C, by using the coordinates as such. Let me begin with A. A is found at 2, 1. So the 2 is here, 1 is somewhere here, in between a 2, as you can see here. So if I have got a point here, like that one, you see that down here is 2, here is 1. So it means this is my point A. And then B, 4, 1. So 4, 1, it is here. Right, again, this is my point B. And then 3, 4. So the 3 is here, the 4 is here. So this is another point. So that one is C. So if I'll take my ruler and try to connect these points here, that will be a triangle that will look something like this. Look at this. So here you join A to B, A to C, and then here I'm also going to join C to B like this. Then finally you connect B and what? And A to have something like this one here. Look at that. So this triangle here is the object. It's found as the object. Now, after enlargement, twice as much. let's look at the nature of the image. So if we enlarge this one, it means there is the new coordinates for the vertices of that triangle are these ones here, A prime, B prime, and C prime. So let us now take note of the points of the image. The first one is A prime, found at when x is 4, y is 1. So x is 4 is here, y is 1. X is 4, y is 1. So this one here is the, here it is supposed to be 2 in multiplication here. So it was 2 times 2, you get a 4. 2 times 1 here is a 2. I was wondering how come it's just a 1 again. Yeah, so here it's supposed to be a 2. Right, now let's go in. When x is 4, y is 2. X is 4 is there, y is 2 is somewhere here. So that one is your A prime. X is 8, y is 2. So you come here again, x is 8, y is 2, so the point is here. Look at that. And that one is your B prime. And then talk of x is 6, y is 8. X is 6, y is 8, somewhere here. So you have the point marked at that position. And that is point C. So you say that one is C prime. So let's see the shape. In terms of the image, so you find that what we have there, now that side C, B, so that is talk of the side C, A. Now it will be C prime, A prime, coming something like this one here. So you can see C, A is now C prime, A prime. It's more like double as much. It means this one has been enlarged twice as much. Then talk of A, B, now it will be A prime, B prime. So compare the sizes. This one, this time around, the sizes are a little bit what? Longer. And then talk of the C, B is enlarged to C prime, B prime. So it means now the size comes in like something like what? Like this one here. So this is what we have. So what we have here are two triangles. One is smaller one, the other one is larger one. So by the scale factor of 2, look at what we have done here. You multiply by the coordinates by the 2 itself, you get the new coordinates as such. Then you consider these are coordinates for the image, this one for the object. Right. So the center of enlargement in this case was indicated to be 0, 0. Right. So as I indicated there at that moment, that time to say, when you are coming up with the talk of the center of enlargement, it is a point where you have the object distance lines of the talk of the image and the object are intersecting. So like here, what do I mean? Here I mean if I can connect A and A. This is A, this is A prime. It means the 2 points are what? Corresponding to each other. I'll connect this one and that one, they produce a line which will come something like this. A prime and A will have something like this. So I'll connect that one and produce a line that will go like this. So if I have got this line here, you find that this line, if it is extended, is going to pass through the what? Point of origin. A prime, A. Or A prime. What if I connect C and C? So for the C and C, I'll also have the same situation here. You'd see that C and C are also forming a line that is going to pass through the point of origin here at point 0, 0. What if I also connect B and a B? Where are they going to pass? B and B. Or where is the line for B and B going to pass? So you find that B and B is also going to behave the same. So if I connect B and B prime, the situation will come like this. And here we go. You find that now you have got that line also passing through the same. So let us try to analyze what we have here on the board. So you find that the line connecting C and C prime extended, and line again connecting A and A prime extended, line connecting talk over B and B prime extended. They're all passing at O. So it is really true that the center of enlargement here is 0, 0. Right. So this is your object. This is the image. Right, so this is what I wanted us to at least understand. Besides enlarging an object directly on the plain paper, also let us realize that it is also manageable, that you can also enlarge an object on the Cartesian plane. So the points of focus here, each time you are given such type of questions, is just a matter of say, how can I enlarge the talk of the figure? What you do here, just multiply the coordinates so that you should have new points, which are just images of a particular object in that case. Right, so what we have done here, I think, is well explained and for the tactics. Right, so before I end, let me give you an assignment where I'll just explain the result. An assignment of which is that you are still going to consider the same example with the coordinates as such, which are namely A 2-1, B 4-1, C 3,4. So what I want to do is, you are going to more like do the same activity, but now what I want to do is just like you are going to enlarge this triangle by using a scale factor that is -2. Right, it's -2. What we have done here, we have used a +2. Remember what I said earlier, to say the nature of a scale factor will determine the status of the image. I indicated that, say, if you are using a scale factor that is a negative, you should expect that, say, the image are somehow different in the sense that the image will always be upside down. So what I expect you to do, and what you are going to observe, I should expect you to have a scenario whereby if your object is like this, and you should expect that the image in this case should at least be on the other side of this triangle, and again should be what? Upside down. To say what was up now will be down. If this is your A, it means your A now will be like this one, it will be like A prime. If this is your B should be here. If this is your C should be here. Like something like this. So you connect it, that C and C, okay, C and you connect B to C, then C to A, something like that. So this is just your image, so you have it to be upside down. And at the very end, you should be able to find the center of enlargement to be right in between this, which is your objective, and the image. That is your expectation about the negative scale factor. Right, so please, can you do this an assignment? You are not going even to face problems here. You just do exactly as we have done, and then connect up the corresponding points. You find that really the center is in between the object and the image as such. But for this one, you find that the object, to go the center is at least away, outside the object and the image. Right, so with this, I have hope that we have knowledge about transformation, and I'm urging you at least to go back and revise all the content we have discussed in all the videos about the transformation. Right, get to know about the type C. We started looking at the translation, and then we came into rotation, and finally now we've ended with what? Enlargement. Right, with that, then I have hope that you guys will do everything possibly well during the exam. Otherwise, thank you very much. We'll meet again in the other videos.